splicing, for example. This is the first
like
question.
in spinal muscular
what's happened to the wild-type expression? So you show that you can revert some global changes in expression. But what are the changes that you have in the wild-type mouse?
In the wild type, what was it, Massimo? Do you remember the total number of genes that were affected? 1,300 or something like that?
1,300 or something like that. A lot of them were in the liver. So I think they treated the liver separately from the other tissues. The liver has the largest number of genes that change expression. These are not big changes. In most of the cases are relatively small changes.
20%, but they're called statistically significant.
Exactly. And so in the liver it's like 800 genes or so, and it's a few hundred in the other tissues. Actually, you may have some of those data in the slide that you have shown, but there has been a preliminary analysis of gene ontology to try to understand what kind of pathways might have been involved, and there is nothing at this point.
This is in the wild type or in the other?
This is in the wild
type.
In the wild type. As a drug genes that change expression as a drug, there is so far doesn't seem to show up anything that is particularly what I can
deleterious.
say deleterious. That is things like oncogenes or this kind of things.
To change the idea of this drug is to change globally the heterochromatin. To change what is silenced and to shut down, to change it. So I would expect a significant effect on the expression.
There may be but that depends very much also from the dose that you're using. Don't forget that here we are trying to open up a heterochromatic region that has been induced by the repeat, and it doesn't. Maybe in order to get a more global effect, you may have to use a higher dose. And in fact, some kind of dose response curves in terms of gene expression are being generated.
Right.
And there are genes that change expression that, for instance, are like repressed with a lower dose and that increase with a higher dose that may represent actually toxic response or stress response that you only see when you go to a much higher dose. So I think those studies are really progressing, but there is nothing at this point that seems particularly of a particular concern.
Can I make a comment about specificity? As far as position effect variegation is concerned, which is what this kind of model is based on, those genes that are subject to position effect variegation are highly sensitive to these kinds of modifiers, either HDAC inhibitors or other kinds of heterochromatin dosage or heterochromatin proteins. And much more sensitive than the general genome. So it seems that if you've got, this is an abnormal situation where a gene is pushed into this behavior, it's going to be more sensitive to these treatments than normal genes, although of course we don't know all the genes, which is why you have to do them on
Right. And data mining is really at just the beginning of these large data sets.
Okay, no, it was this lady that asked first.
Yeah. Is it my turn?
Yes, please.
I always thought that when this DNA gets unwrapped, this would lead to a sort of uncontrollable situation. And if I have understood correctly, this does not happen. But on the other hand, you say there is no therapy yet. So my question is, how optimistic can we be, and what remains to be done before we get this therapy?
Well,
In terms of toxicity, the compound that we've used at high enough doses is toxic. And so that's the point of Repligen synthesizing a library of 120 compounds to improve on the therapeutic index. So right now, the compound 4B, as the drug discovery industry says, has a therapeutic index of 5. Its effectiveness only happens 5-fold lower concentration than where it stops cell division. Right? So we have to improve on its therapeutic index and then do full preclinical assessment. That's very expensive. About a year from now, we should know where we are as to whether we have a clinical candidate that can be taken forward into phase 1 trials. We don't know that.
Michel had a question.
Yeah, maybe I missed the point, but about the R6 mouse, the Huntington model, what are the evidence or the rationale you have to say that drug acts on the polyglutamine toxicity rather than just shutting down the expression of the transgene?
Oh, no. That was tested. So the transgene is expression is not changed, and in some preliminary RT-PCR experiments that Beth Thomas has done, she's looked at genes whose expression is known to be downregulated in the brain of those animals, and some of them are upregulated by the action of the compound.
So it's target genes that are dysregulated by
all
that correspond to
yes. But a full microarray analysis is just in progress on that.
All right. Thank you very much, Joel. And I think we move to the second part of this session.